Hello and welcome to C3 Streamland. So in this video, which is a continuation of properties of circle, part 5, we'll be talking about chords again, a little bit more about chords. Now, as you can see, chord is any segment on a circle where the endpoints of the chord or endpoints of that segment lie on the circumference of a circle, right? And that is defined as a chord. And chord basically divides circle in two arcs. One is minor arc, which is the smaller portion of the circumference, and another one is major arc, which is the larger chunk of the circumference, right? Now these chords can be anywhere. So if I move this point around, so this is also a chord, this is also a chord, all these are chords. Now I wonder which one, where is the largest chord of the circle? Is it possible to construct a largest chord? Now let's move this point around the circle and let's see how much it is stretched. Now as you can see, the moment I cross the center of a circle, the moment I go on the other side, the chord begins to shrink again. But then as I go near the circle, the length of my chord is increasing, and the moment I cross over, it starts decreasing. That means there is some point here at the center which creates the largest chord for me. But do we have another name for this chord? Can you think about? I mean, we talked about this when we were talking about the circle family. And this largest chord, we can also call it a diameter of a circle. So we can say that diameter is the largest chord of a circle. And there you go. That is another property of the circle. The diameter of the circle is the largest chord in the circle. You cannot construct a chord which is larger than the diameter of a circle, right? That is first property. Now let's see what happens to the distance between the chord and the center when we are making the larger or smaller chords. So for that, let's quickly divide our chord in a perpendicular with a perpendicular line, because that will give us proper distance idea for the distance. Let me define this point of intersection. This time I'm going to define it only on the chord segment, and let me hide the line. Let's quickly create a segment for us to understand what's happening with the distance AD. We can call it. So the distance is defined with the segment AD here. And let's move around with our chord in a circle. And as you can see, as my chord is increasing, my segment AD is getting shorter. And as I'm going away from the center, segment AD is getting longer. Now to understand it mathematically, let's quickly define the distance of segment AD, and it's at this point it's 1.93. Now let me move that again, and as you can see, when I'm moving, the distance is changing, it's decreasing. Now it's 0 point something, and as I'm going away, it's 2 point. So basically the distance between the center and the length of the chord are in reverse proportion. The distance between the center and the chord increases, length of the chord will decrease. And if the distance between chord and the center is decreasing, then the length of the chord will increase. Did I say the same thing? Let me try that again. So when the distance between the center and the chord increases, the length of the chord decreases. But when the distance between center and the chord decreases, the length of the chord increases. Yes, and which that is the another property of the circle. Now here I would like to stop, and in the next video we can discuss two more properties which are related to the diameter of a circle. Happy